Hello friends, as you know that in plus 2 syllabus or the 11th and 12th syllabus, electrostatics is a topic which is very important from the examination point of view as well as from various examination and entrances examinations in engineering and also in medical. So today we shall discuss about the electric field intensity due to a dipole and about the dipole. As before this class we have discussed about the Coulomb's law. You can find out in another link. So in this class we shall discuss about the electric field due to a dipole. Electric field due to a dipole. So what is a dipole? First of all, first we have to know about the dipole. Dipole, an electric dipole consists of a combination of two equal and opposite charges separated very close to each other. That means if you are thinking about two charges, let this is a charge and this is a charge. Two equal and opposite charges. Let this is plus q and this is minus q. They are separated by small distance. Let this distance be 2a. Okay. Here this is a point A and this is a point B. A is a point and B is a point where A at the point of A plus Q charge is there and at the point B minus Q charge is there. So and they are separated by a small distance. This is taken 2A because we have to make a calculation for different points. So I have taken this one 2A for better calculation. Okay, but it is very small distance. Then this is called a dipole. That means an electric dipole consists of combination of two equal and opposite charges separated by very small distance. Okay. So today we shall discuss about this electric field due to a dipole. So in this dipole we have to calculate the electric field in 2 points. One on the axial line. Let this is a point P on the axial line and another on equatorial line. So first of all, we have to know what is a equatorial line and what is a axial line. Axial line means a line joining the two charges and passing through the center of the dipole is called its axial line. Be remember, a line joining the two charges and passing through the center. Okay, this is a charge plus 2 charge and this is minus 2 charge, and this line is passing through these 2 points as well as through the center. Let O be the center of the dipole and P is the point where we have to calculate. So first of all we have to think the electric field due to a dipole. Case 1 on axial line. Okay, on axial line. Axial line means the line exists on its axis. The line which is passing through the 2 points as well as the center of the dipole, and P be a point which is situated at a distance. Let this is distance R from O. Here A and B 2 points where at A we have placed a plus 2 charge and B we have placed a minus 2 charge, and P is a point which is situated at a distance R from O. Now let this is, as we have taken this is 2A, so this distance is A and this is distance also A. Okay, so it becomes 2A. Okay, for better understanding I am telling this one, explaining, just remember, let A is a point and P is a point. Let two charges plus Q and minus Q which is situated at a point A and B and separated by a distance 2A, and P be a point on the axial line which is situated at a distance R from O. Okay, now we have to calculate this distance AP, that is equal to R minus A, and this BP also necessary. This is equal to R plus A because this distance is R, this is A, so this becomes R plus A. This distance A, this is R, so it becomes R minus A. Okay. Now we have to calculate the electric field intensity at the point P due to this plus q charge and due to this minus q charge. So as we know, the electric field intensity, that is E, is equal to 1 by 4 pi epsilon 0 q by r square for any point, for any charges. If the q is the charge, then this is the formula or the equation for finding out the electric field intensity or electric field. So at this point P, we have to calculate the electric field due to this plus q charge and due to this minus q charge. Now we are going to calculate the electric field at this point P due to this point charge plus q. That means, let this is E1. Okay, this is for our knowledge E. So we are taking the electric field intensity at P due to this plus q charge. That means that is equal to this E1, that is equal to 1 by 4 pi epsilon 0 q by distance, that means AP square. AP square, that is equal to 1 by 4 pi epsilon 0 q by AP. AP distance is equal to r minus 0 whole square. Okay. Similarly, electric field intensity by electric field at the point P due to this minus q charge is equal to 1 by 4 pi epsilon 0 q by Bp square. That is equal to 1 by 4 pi epsilon 0 q by this distance equal to r plus a. So this becomes r plus a whole square. Okay. So at the point P, the electric field intensity due to this plus q charge is equal to 1 by 4 pi epsilon 0 q by r minus 0 whole square. Similarly, at the point P, the electric field due to this minus q charge is equal to 1 by 4 pi epsilon 0 q by r plus a whole square. Now we have to summarize or calculate the net intensity, electric field intensity at the point P due to these two charges. Then we'll omitting this one. Okay. Net E is equal to, this is the nearer point, so this is E1 minus E2, or equal to E1 equal to how much the E1? 1 by 4 pi epsilon 0 q by r minus a whole square minus, this is 1 by 4 pi epsilon 0 q by r plus a whole square. Okay. So net electric field intensity at the point P due to these two charges is equal to this one. So you can calculate this taking common 4 pi epsilon 0, it becomes q by, q can be taken outside, it becomes 1 by r minus a whole square minus 1 by r plus a whole square. Okay. This is q on both sides. This is q, this is q. So taking outside 4 pi epsilon 0, 4 pi epsilon 0, I have taken common. So it becomes this one. Now it becomes q by 4 pi epsilon 0. Taking outside, the LCM is r minus a whole square, r plus a whole square. That means r square minus a square whole square. Okay. Now we can divide this one with this one. It becomes r plus a whole square minus, just for memory, we can take this one, r minus a whole square and r plus a whole square. It will be better to understand. After this, we will multiply that one. This, divide this one, it becomes r minus a whole square. Okay. So it becomes q by 4 pi epsilon 0. How much? R plus a whole square. That means r square plus a square plus 2ar. Okay. Similarly, r minus a whole square is equal to minus r square minus a square plus 2ar. Okay. By r square minus r plus a whole square, r minus a whole square. So it becomes r square minus a square whole square. R square minus a square whole square. Okay. Just omitting this one. So how much we get? This is equal to q by 4 pi epsilon 0, cancelling r square and a square, it becomes 2ar, 2ar, that equal to 4ar by r square minus a square of 4 square. This is the net electric field due to these two charges. That means the electric field due to these two charges at the point P, that means the on the axial line is equal to this. But we have to do some more calculation. I am omitting this one. Just to see. This is equal to q by 1 by 4 pi epsilon 0 into this q. I am taking this side and making this one 2 into a into q into 2r. Okay, 4ar into q. I have taken this one 2aq into 2r by r cube minus a square. Hello, as you know, 2aq is equal to p, where p is called the dipole moment. So you can place this p here. It becomes 1 by 4 pi epsilon 0 p into 2r by r square minus a square whole square. Okay. Now, as we know, the value of this a is very negligible as compared to the value of this r, because r is far away. A, r greater than a, r square greater than r greater than a, and r square greater than a square. So we can neglect the term what? A square. We can neglect the term a square. If we are neglecting this term a square, it becomes r square to the power square, that means r fourth. So it becomes E is equal to 1 by 4 pi epsilon 0 to r into p by r fourth. So you can cancel 1 r from here to this side. So it becomes 1 by 4 pi epsilon 0 to p by r cube. This is the electric intensity at the point P due to these two charges. So this is the equation for electric field intensity due to a dipole on its axial line. We remember this one. It is very important from the examination point of view. Here two units, two sub units are there. One is on the axial line. So we find that electric field is equal to 1 by 4 pi epsilon 0 to p by r cube, where when a point P is situated at a distance r from O on the axial line. Okay, so this is the equation. Memorize this one. Now we will go to another point which is situated on the equatorial line. Second case, case 2, that is on equatorial line. So what is equatorial line? One is axial line, when the line passing through the 2 points or the 2 charges and through the center of the 2 charges, then that is called our axial line. Now on equatorial line, when we are going for equatorial line, if this is similar charges I am taking for our consideration or for memory, it will be better. I am not change this one, A and B. Okay. Now equatorial line, a line passing through the center of the dipole and perpendicular to the axial line. We remember, center of the dipole, line passing through the center of the dipole and perpendicular to the axial line. This is the axial line. If it is perpendicular, then this is called a equatorial line. Let the point P be situated at a distance r from O. Okay, on the equatorial line. We have to calculate the electric field at the point P due to this plus Q charge and due to this minus Q charge. Now we are joining this and this. Okay, as you know, AB is separated by a distance 2A. Okay, that means this is A and this is A. Okay, this is R and this is A. It is perpendicular. Then it becomes R square plus A square root of. Similarly, this becomes R square plus A square root of. At the time only we will use this one. Okay. Now we have to calculate the electric field due to this plus Q charge at the point P. Okay. Let this is acting along this direction. And this is C. Okay. As it makes an angle with the horizontal, so it resolves into two components. Let the electric field intensity by electric field due to this plus charge at this point P be U1. That this is U1. Then U1 is resolved into two components as it makes an angle theta. So this is resolved into two components. Okay. One component is in this direction, one is this direction. As it is vertical component, so it becomes U1 sin theta. As it is horizontal component, it becomes U1 cos theta. Okay, give some name here. Let this is O, P, this is D. Okay, this is as we are using E, I am not taking this on E, F. Let this is F. Okay, so the electric field, here the electric field intensity is acting along this direction. So it resolves into two components. One is U1 sin theta, another one E1 cos theta. Similarly, at the point P, due to this minus Q charge, the electric field is acting. It is also making an angle theta, so it is also resolved into two components. That means this is acting along this direction, so it resolves into two components. That is E2 sin theta and E2 cos theta. Okay, now I am describing this one, just listen. Then we will go for mathematical calculation. Okay, we have taken two charges, plus Q charge and minus Q charge at the point A and B, which are separated by a distance 2A. Okay, O is the center of the dipole, AB is the dipole, and O is the center of the dipole. As we have drawn a perpendicular line through the center, so a point P is situated at a distance r from O. We have to calculate the electric field at the point P due to this plus Q charge and due to this minus Q charge. Okay. Now for this, to find out this electric field due to this plus Q charge, I have drawn the diagram along this direction. The pulse is acting along this direction. It resolves into two components, that is U1 sin theta along ED and U1 cos theta along EF. Similarly, here another charge is here at the point B, that is minus Q. It is also acting, we have to calculate the electric field due to this minus Q charge at the point P. So it is also resolved into two components, that is one E2 sin theta along EO and E2 cos theta along PF. As we have seen, this E1 cos theta and E1 sin theta and E2 sin theta are acting opposite to each other and are equally in magnitude. They cancel each other. So the net electric field intensity due to these two charges are acting along this PF, which we have to calculate. Okay, that means the E1 is resolved into two components. That is E1 is resolved into two components. What are they? E1 sin theta along which direction? PD, along PD. Similarly, E1 cos theta along which direction? PF. Similarly, E2 also resolved into two components, that is E2 sin theta along which direction? E2 sin theta along this direction, PO. PO. Similarly, E2 cos theta along which direction? This direction, PF. See, E1 sin theta and E2 sin theta. E1 sin theta along this direction and E2 sin theta along this direction. So they are equal and acting in opposite direction, so they cancel each other. So net electric field remain along these two. That means the net electric field, that is equal to E1 cos theta plus E2 cos theta along PL. Okay, we are adding these two. Then we will get the net electric field intensity. Okay, so it becomes net electric field intensity, that is equal to E1 cos theta plus E2 cos theta. Okay, now we have to calculate this E1 and E2 and cos theta. As the E1 and E2 are two charges are same, so this value of E1 and E2 are same, so it can becomes 2E1 cos theta. Okay, that is equal to 2 into the value of E is equal to 1 by 4 pi epsilon 0 Q by R square. R means AP square or BP square. It is equal. This is AP square into cos theta. Cos theta. Okay, we are calculating on equatorial line. So 2 into 1 by 4 pi epsilon 0 into Q by this AP is equal to R square plus A square root over. That is R square plus A square root over into whole square. Now we have to calculate this cos theta. Here the cos theta is equal to in triangle AOP. In triangle AOP. Okay, cos theta is equal to B by H. That means A by R square plus A square root over. Okay, put here A by R square plus A square root over. So it becomes 2 into 1 by 4 pi epsilon 0 into Q into A by R square plus L square to the power root over whole square. That means root over cancelling. 1 by 2 into 2. So it becomes 1 and the root over. That means 3 by 2. Okay. Using some values here. Just see. How we get it? That is equal to 2 into 1 by 4 pi epsilon 0. 2 I am taking here. 2QA by R square plus A square to the power 3 by 2. Okay. Okay. Now using this one. See. It becomes 1 by 4 pi epsilon 0. As you know, 2QA is equal to P by R square plus A square whole to the 3 by 2. Okay. As you know, this R and A in comparison to R, A is very small. That means R greater than A. So R square also greater than A square. That means A square term can be neglected. A square term can be neglected. So it becomes E is equal to 1 by 4 pi epsilon 0 P by R square to the power 3 by 2. 2 cancelling out. It becomes 1 by 4 pi epsilon 0 P by R cube. So this is the electric field at the point P due to a dipole, where P is the point on the equatorial line. Okay. So on the equatorial line we find, now reaching this one. So we remember 2 points which are very important from examination point of view. When we have calculated first case, that is on axial line E is equal to 1 by 4 pi epsilon 0 2P by R cube. Okay. Similarly on equatorial line line E is equal to 1 by 4570 P by RT. Okay, these two equations are very important and it will be helpful for different kind of problem, for finding the solution of different kind of problem. Okay, thank you.